so we know what a polygon is. I know we covered it in the past. For us to see it, a polygon is a closed figure where the sides are straight. I have a pentagon, I have a hexagon. And I remember back in the days when we covered it, I gave you guys a list of names. So we know that's a polygon. Now the word regular, if we're dealing with regular polygons, the word regular, what it means is the length of each side is the same. So if I give you guys on my pentagon and I say one side is 5, you know each side is 5. And then at the same time, if I give you guys one of my degrees, if I tell you guys, degrees is a certain thing, you guys know all my degrees are the exact same thing. Like if I come and say this is 72, you know each degree, each corner is 72 degrees. Right? So that's what makes it a regular polygon. The same thing with the hexagon and so on and so forth. So my formula for today works only for regular polygons. In real life, we might deal with polygons that are not regular, but for the worksheet for today, they will all be regular. Now, on a regular polygon, or any polygons, I can just use the radius, or in this case, plural, we call it radii. I can just use the radii that creates triangles. You notice my pentagon, I created 5 triangles. My hexagon, I created 6 triangles. You guys see, those are my radii. If I was to extend it, if that was a piece of paper, and I cut it out and I extend it, it looks like a bunch of triangles. Now, for this thing, the interesting part of polygons, I'm going to introduce you guys flexing. I'm going to introduce you guys to this measurement. It's not the radius. The radius is the dotted one. This other one, we're going to call this asymptote. So I'm using A for that little part. That part, it's not the radius, is what we call the asymptote. Some people pronounce it asymptote, some others pronounce it apotome. I don't know which one's the right pronunciation. You can ask your English teachers, and then some of them will use one, asymptote, and then some others will call it apotome. So I would call it asymptote, but like I've run into some math teachers that are like, no, it's apotome. And then some others like, no, it's asymptote. But I'm just going to go with asymptote. Okay? So having this said, we're going to talk about the area of it. So for what I'm going to do, as an example, I'm just going to refer to my pentagon. Do me a favor and graph that pentagon to begin with. Graph it with the triangles, because I want to emphasize, if you want to put, I put an A on the asymptote. If you're going to put the whole name for it, you can go for it. Like I just want to emphasize that to begin with, it cuts into triangles. I'm not going to have you guys do the hexagon. We're just going to go with the pentagon. And then once you finish copying it, do me a favor and copy that as well. Let me take roll meanwhile. So I have that to calculate the area of a regular polygon, we can divide the polygon into triangles and add the area of the triangles. And that's one way we can do it. Divide it into triangles and add the area of the triangles. But a faster way of doing it is 1/2 times P times A, where P stands for perimeter and A stands for aperture. That way I take care of all the triangles at once. The faster way of doing it is 1/2 times P times A. Remember, my perimeter is basically all the sides times aperture. You'll see a few pencils moving. Remember, to calculate the area of a regular polygon, we can divide the polygon into triangles and not the area of the triangles. Faster way of doing it is 1/2 times P times A, where P stands for perimeter and A stands for aperture. Sometimes I get asked, what's the difference between geometry CP and geometry gate? Like, why do you, when we calculate a GPA, an A for geometry CP is 4 points, but an A in gate is 5 points? Like, why do they get more? One thing that I can do, that I can tell you guys, what we do with the gate classes, or what we encourage on the gate classes, is that we don't give them the aperture. We give them the radius instead. Now, the radius is the dotted line, so I can come and say, well, that's 5. I'm going to give you the radius is 5. And let's say the whole side is 6. And then from there, they have to be able to calculate the aperture. One way they can do it is, they come and say, well, the aperture, I can split it in 3 and 3. I mean, the side, I can split it in 3 and 3 because the aperture goes in the middle. So they're looking at a triangle. And then you guys are familiar with Pythagorean theorem, a squared plus b squared equals c squared. So they do it 8 squared plus 3 squared equals 5 squared, and then they will figure that the aperture is 4. Once they find the aperture, they have to calculate the area of the polygon. With you guys, like geometry CP, I come over and give you the measurement of the aperture. You just have to find out the area of the polygon. Like I said, with them, we give them the radius. They have to calculate some more. And also with CP, I do many examples. With gate, we kind of back up a little. We kind of explain a little, but gate, they need to figure out things on their own. So that's one of the differences between gate and CP, if you guys ever wonder. Can I take this out? Yeah. All right, let's take a look at our homework. Take a look at our worksheet. So the formula was 1/2 times perimeter times aperture. If I said that we were going to do 1/2 times perimeter times aperture, so 1/2 in a calculator, I'm going to call it 0.5. The perimeter for this case, I noticed there's 7 sides. Each side is 11.6. So my perimeter should be 11.6 times 7. Okay, the 7 because there's 7 sides. So the perimeter is 11.6 times 7. And my aperture in this case is a 12. Right, it's given. It's 12. So I just have to multiply those out. Do keep in mind it says round your answer to the nearest tenth if necessary. You know, tenth sounds like 10. I know the number 10 has 1 0, so nearest tenth means 1 decimal place. If I said 100th, 2 decimal places. So nearest tenth, I'm saying 1 decimal place. If you guys multiply everything, 0.5 times 11.6 times 7 times 12, you should get 487.2. That's it. Like I said, with you guys, I will give you guys the answer. Take a look at question number 2. Once again, I know the formula is 1/2 times perimeter times aperture. I know the formula, I gave it to you guys in your notes. If you guys can highlight it or something, that way you guys know where it's at, that would be nice. I know sometimes I see people write notes on their worksheets, on their homework, but do remember I don't give the homework back. So anything you write on the worksheet, I'm going to keep. Anything you write on your notes, you'll be able to keep. So I encourage more to write it on the notes. Okay, so I know 1/2 times perimeter times half of them. So 1/2 in the calculator is 0.5. The perimeter, I'm looking at each side is 15.6. But I'm going to multiply times 6 this time because there's 6 sides. And then I notice the apothem is 13.5. Right. If you grab a calculator, you multiply that out, you should get 631.8. Let me take a look at question number 4. So I'm going to skip 3. Let me take a forward. I know yesterday we talked about triangles, and then for a triangle was 1/2 times base times height. Technically, you have the base, because you can stand it on that. Technically, that side is 15.6. But now this is not the height. This 4.5 is not the height. And we cannot come and assume that's half of the height, because you can see that 4.5 is not half of the height. So since you don't have the height, you have an apothem, use your formula, 1/2 times perimeter times apothem. Remember back in the days, I used to ask you guys, I would give you guys a triangle. I used to ask you guys for a circle that touched all 3 corners. That point is that point. Like the apothem comes from that point, from the center of that circle. Like I said, so it's not the half of the height, it's what we call our centroid. Okay, so now here, I'm gonna go 1/2 is 0.5. The perimeter is 15.6 times 3, and then the apothem is 4.5. I'm just gonna go ahead and multiply everything across, and I get 105.3. Just because you see a triangle, don't think it's like a triangle like yesterday, because you don't have the height. You have the apothem. Yes. So simple. Any questions?